In this video, we're going to take a look at diesel fuel injectors fundamental and service. And these are injectors themselves. We've taken a look at how the high pressure is created in the injection pump. And then from there, we go into the jumper lines and then into the injectors. And we're going to take a look at how these injectors work. So basically, if we take a look at how a mechanical injector is set up, and they do vary between manufacturers, and we're going to take a look at how different ones work. We're going to take a look at hydraulic injectors. And a hydraulic injector would be this one that's right here. Now, these mechanical injectors are a little different. This is what Cummins uses, and they create their pressure within themselves. But this one here uses a jumper line. And then, of course, when we get into electronic injectors, they're a little bit different. So if we take a look at, and we've talked about how injection pumps are set up. So every injection throughout the system delivers exactly the same amount of fuel so that we get a very balanced engine. So we have our injection pump and we have our high pressure lines that go up to our injectors in the head. Now, a basic hydraulic injector is the nozzle tip is closed, but the components we have our high pressure line that comes in from our injection pump. We have a cap, we have a spring and a jam nut, and we have a nozzle or a needle. Now, this spring keeps this needle closed, and it's hydraulic pressure or fuel pressure underneath that causes the injection to happen. We also have a leak-off line, so any fuel that does get past here, we want it to leak back into the tank so it doesn't hydraulically lock this injector from working properly. So most of the ones that we see are multi-orifice. So we have our nozzle assembly, we have our intermediate plate, we have our spring, and this keeps the needle seated down against the pocket here. When we're servicing any of these, usually you take them all apart, you put them in an ultrasonic cleaner, and you leave it for a while, and it cleans all the components, and then we inspect them and reassemble them. Last line of defense is on some of them, they will have a filter screen, and this is to pick up any particles that may get past the injection pump. So two different styles that we're going to take a quick look at. The multi-hole needle. So this one here has a bunch of different orifices at the very, very tip of this. And again, it all depends on the manufacturer, whether there is 4, 6, 8, however many they want. They're really, really small holes. So any little particles that get in there can block off these, and we could end up with problems. The other style that we take a look at is a pintle nozzle, and it has just a single hole, and it sprays in a cone pattern as it sprays out. So if we take a look at the needle valve itself and the body, and again, this needle valve sits inside the body, and same with when we take a look at the pintle style. So how does it work? Well, here's our needle and here's our body. And what happens is this is all filled with fuel. This is open to combustion pressure. Now, as the injection pump starts to push fuel out, again, remember that in this situation where liquids are virtually incompressible, as soon as port closing happens, that's the beginning of injection. Pressure rapidly rises in this area down here in the pressure chamber. And what happens now is the pressure pushes up against this area here and pushes this needle valve up against spring pressure. Once that happens and this opens, we get the beginning of injection. Like I say, this happens rapidly. As soon as port closing happens, this starts. So with the amount of pressure that's coming in here, this is going to stay off its seat until spring pressure can overcome the fuel pressure in this pressure chamber. Once that happens, this is going to close again, and that will be the end of injection. Now, when we're looking at testing injector nozzles, what we're checking for is we're checking for spray pattern and make sure that none of the little holes are plugged off, so we get a perfect spray pattern. So carbon buildup is a problem on these things, and we get carbon buildup, and it can plug off a nozzle. So a multi-hole orifice, again, this one here has probably 8 holes that run around it. They're low pressure, so we're talking 2,000 to 5,000 psi. When we get into pintles, they're 1,400 to 2,000 psi. And this pressure here is the pressure that's coming out of the injection pump. Now, these do vary. Now, when we were talking about it in the shop, what we want to know is what is the cracking pressure of our injection nozzles. So at what pressure does this lift off its seat and spray? And those are the ones we can go in and we can adjust. Now, some are adjusted by turning a screw. Some are adjusted by adding shims to increase or decrease the pressure. And we want them all to be exactly the same. So if our specification says that the cracking pressure is 2,000 psi, we want them all as close as we can to 2,000 psi. If they start delivering at 1,400, that means that it's going to be starting to deliver early before the pressure has a chance to build, and that would advance our timing. If they're over 2,000, that's going to retard the timing. So one thing we got to pay attention to when we're working with pencil injectors is never pry on them to get them out, because if we bend this, then that injector is useless. So taking a look at how they're set up in the machine, again, the injector fits in the cylinder head, and in most cases they are accessible to the mechanic. You don't have to pull off any covers. We have our high pressure jumper lines that run from our injection pump up to our injector, and then we have bleed lines, and again, this returns back to the tank. One of the things when we're pulling the injector, make sure you take a look and a lot of the injectors will use a copper or brass washer at the very bottom. When you pull the injector, you got to make sure you take that out also. And there's an injector um, heel bar that you can go in there, put it in there, and take that brass washer out. Because if you try and put it in with 2 brass washers, the spray pattern isn't going to be exactly perfect. It's going to sit higher, so our spray pattern isn't going to be where we want it to be, and we could end up with problems. So on an air-cooled engine, again, we have our high-pressure jumper lines and our drain line to drain any buildup of extra pressure or leakage past the injector nozzle, so that it goes back to the tank, so we don't hydraulically lock that injector in place. So taking a look again, how they're put in position. So again, some of these are set in that they don't need a copper washer. If they have a flat bottom, they may need. So always check the specifications. And again, we have our spring and our adjusting nut, and then there's usually a cap on top of this to protect this so it doesn't come out of adjustment. The nozzle holder, again, is held down by 2 bolts, or it could be a clamp that holds it in place, and our high pressure injection lines. So when we're going to clean them and reassemble them, we're going to put them in a tester and we're going to adjust this so that our opening pressures are all the same. All right, so this is a test bench for testing the injectors. So we build the pressure and see at what point they crack. Anytime that we have to do any work on injector nozzles, one of the things we really have to pay attention to is making sure that this area is perfectly clean before we service any of these. Anytime we take the caps off or the high pressure lines, we should be capping the top of this so nothing gets inside. Any of these high pressure lines, same thing is we're going to pressure wash this whole area. And one of the things to keep in mind is never spray an injection pump with hot water if you're going to be starting it within the next few minutes because temperature change could cause that injection pump to seize up. So if you're going to wash this, leave it for 10-15 minutes before you start the engine so we don't end up with any issues. So again, this is a good indication that we have some leaking around the injector itself from fuel. And it could be from where the seal surface is, or it could be a little bit from the high pressure line, or it could be our return line is starting to leak. So again, putting protective caps on the injectors once we remove the high pressure lines so no dirt can get in there. When we're undoing these lines, be very careful that we don't crimp them because if we twist the line, it's going to restrict the flow and we're going to end up with problems. The other thing is when we're taking all the lines off, there's these clamps and these are usually rubber mounted and they have to go back on because every time that injector or the injection pump fires to a cylinder, it gets a pulse. If we don't put these clamps back on, we're going to either bust off right at the injector or down at the pump. It's just going to snap. And it doesn't take very long, a couple hours if we forget. So always make sure that these are clamped back in place. Now, if we take a look at the injector lines, they're all exactly the same length, but they are made for each cylinder. Now, why do we want them all the same length? Well, we want them all the same length, so the amount of compression, even though we say fluid is virtually incompressible, there is some compression in there. So as long as all the injection lines are exactly the same length, we're going to get the same amount of compression in that fuel, and it's going to be even throughout the engine. Again, when we're working with these hold downs, make sure we put the proper torque to hold this injector in place because if we tighten it down too much, we could theoretically wreck the cylinder head by trying to force that injector tighter into the cylinder head and bust out the bottom of it. If you take a look at these bleed off lines, there's usually a copper washer on each side. These copper washers are usually a one-time deal. So once they are crimped on there and torqued down, if you take them off, you're supposed to replace them. So a work around that is not in every case do we have these copper washers available. So some very fine emery cloth and a little bit of oil, and we can actually clean those up and reuse them again. Again, if we end up with any leaks, we have to fix them and replace them. So taking a look at our injection pump, this is on a little 8-cylinder, so it's a little V pump. So we have our governor assembly, we have our high pressure jumper lines that go out to our injectors that are inside our head. So here is one of the options or odds ones that we have to actually pull the cylinder head to get to the injector. Anytime we're undoing the lines on the injection pump, we should always use 2 wrenches. We can actually undo these if we're just using 1 wrench. Again, if you see that this is starting to twist, we should stop and figure out how we're going to get this off without twisting this line. Because again, if we twist it, it's going to damage it and then it's going to be useless and we have to get a new one. Again, taking a look at the transfer pump. A lot of them do run off the cam on the older style port and helix systems. And in shop, we are looking at going through and testing our injectors to make sure that they're cracking at the proper temperature or proper pressures. And the other thing we want to look for is a couple things. So first thing we want to know is it cracking at the right pressure? Is our spray pattern good? And do we have any leakage after we're finished? So again, when we pull down on the handle, you're going to hear that injector chatter. And what it is the injector is opening and closing because we can't bring the pressure down fast enough to keep it spraying for a long period of time. Chattering is good. And again, what we're looking for is the spray pattern. And once it's finished, do we have any leakage afterwards? And if we do, then that is an issue because we have a leak in our needle in our seat. And that means that fuel is going to get in there after combustion finishes and it's just being wasted. So if you take a look at this type of nozzle, again, depending on the manufacturer, this may have a copper washer down at the very bottom. When we're doing our spray patterns, again, because this comes out as a very fine mist, we want to do it in a chamber where we're not breathing this mist in. And this is what we're looking for after the nozzle is finished injecting is, do we have any leakage out of the nozzle head? So if we have a really good piece of test equipment, we can bring it up. Let's just say our nozzle pressure opening is 2000. We can bring it up to 1950, and we're going to check for any leakage beforehand. Then we're going to open it all the way, make sure it chatters properly, and then we're going to check for any leakage afterwards. Using pyrometers, it was again off the exhaust is checking the exhaust temperature. Now, what about an engine that misses? Now, there's a couple things we can do. Is sometimes depending on how bad the miss is, we can actually feel the high pressure injection lines, and we can feel whether it's firing or not because of the pulsations. But the best way to do it is crack the injector line itself. So if we crack the injector line, it means that that's not going to fire that cylinder. And what we're listening for is, does it change the RPM? So if we crack number one and the RPM changes, it means number one is fine. So if we crack it and it doesn't change, that indicates that we have a problem with either the high pressure line or the injector itself. Another thing that we really have to pay attention to is when we put our high pressure lines back on, is the nut at the top. Don't force it back on, or if we cross thread it, then we're going to end up with damage and it may not seat properly, and then we may have a high pressure leak. And that's the end of this diesel injector service.